morning everyone. In last class we discussed about gradients and uses of gradients, and also we discussed about angular circular motion. We discussed about angular displacement, angular velocity and angular acceleration. Is that clear? And finally we discussed about circular motion. Is that clear? So today we are going to talk about uniform circular motion. Is that clear? First of all, let me tell you what is the difference between circular motion, uniform circular motion and non-uniform circular motion. So I told you that if we take in the uniform circular motion, I am choosing 4 points, point A, point B, point C and point D. So first I can take the velocity of the particle at point A is in the direction of this. It will be tangential. So this is the velocity of the particle at point A. And the velocity of the particle at point B will be tangential. This will be the direction of velocity of the particle at point B. This is V2. And the direction of the velocity of the particle at point C is along this direction. This is V3 and this is V4. So in the uniform circular motion, so what is the uniform circular motion? For example, you can take. So this is, you can take, if you rotate like this, here you can see that. It's called a horizontal circular motion. We know that merry-go-round, it's called as a horizontal circular motion. Is that clear? So in the horizontal circular motion, at every point, point A, point B, point C and point D, each and every point, the magnitude, which means the value of velocity remains in the magnitude is same. What about the direction? Its direction, you can see that here it is acting along this direction, here it is acting along this direction, here. So at each and every point you can see the direction of velocity, that is keep on changing. So this is called uniform circular motion. Uniform circular motion is also called uniform accelerated motion because at every point there is a change in the direction of velocity. So we can change the velocity by two ways. The first one is changing the magnitude of the velocity, and second thing is changing the direction of velocity. But coming to the uniform circular motion case, at every point the direction of velocity keep on changing, and because of that the velocities also keep on changing. When there is a change in velocity with respect to time, so we are calling what? Acceleration. That's why I told you uniform circular motion is also called uniform accelerated motions. Coming to non-uniform circular motion. So what is the non-uniform circular motion? If you take the same thing, if you rotate like this, it's like a chain wheel, it rotates like this. We are rotating in the vertical direction, in the vertical circular motions at every point. Exactly. Please understand this one. The first case, we rotated the stone like this. But in this case, we are rotating along this directions, along like this. It's called vertical circular motion. Is that clear? So in this case, if you rotate this case, you can see that. So when I am rotating this one, you can see that. So when I am rotating this one, it is moving against the gravity, In some point it is moving against the gravity, in some point it is moving towards the gravity. And because of that, if we choose the velocity at point A and point B and point C and point D. So in non-uniform circular motion, I told you some part is moving against the gravity. Suppose if the stone going like this means what will happen? The point A is moving against the gravity, and point B also is what? It is some height from the what? Ground level, and also there is a gravity influence. At every point there is a gravity influence. Is that clear? And because of that, in non-uniform circular motion, the direction of velocity will be like this. Direction of velocity. Is that clear? So in non-uniform circular motion, so what I am telling, that we know that looking into the picture, we know that the direction, I can write, direction keep on change. Is that clear? Then what about its magnitude? I told you, in some point, if we take any point, it moves against the gravity, and some point towards the gravity. And because of that, at every point, the value also will keep on change. Is that clear? So here, the magnitude remains same, only the direction is changing. But here, at every point, the magnitude of the velocity will be differ. The value of the velocity will differ. So I can take in non-uniform circular motion, magnitude and direction keep on change. Keep on change. Which means if you want to know the value of velocity at point A, just to say I can take 5 meter per seconds. The velocity, the magnitude of the velocity at point B is called 4 meter per seconds. I'm just taking for the example. And here it will have something, and here it will have something, and you can see that at every point the value of velocity, the magnitude of velocity is keep on changing. Is that clear? And the direction is also keep on changing. Is that clear? So that is the main difference between uniform circular motion and non-uniform circular motion. In uniform circular motion, the magnitude is remain same. Is that clear? Which means the horizontal motion, the magnitude is remain same, but the directions keep on changing. But coming to what? Vertical circular motion, at every point there is a change in the value, which means there is a change in the magnitude and as well as change in the direction of what? Velocity. Is that clear? So our topic is what? Our topic is called uniform circular motion. So what I told you, due to changing the direction, there is some acceleration towards the center. There is some acceleration towards the center. Because this is because of what? I can take. So because of changing in direction, there is an acceleration that's called what? Centripetal acceleration. Due to changing direction. At every point there is a changing in direction, and because of that there is some acceleration towards the center. And next you can see that you can take, this will be tangential, you know. This will be tangential and this will be tangential. Suppose if you want the velocity at this point, this will be tangential. Is that clear? But here you can see that at every point in the tangential to the circle, this will be tangential to the circle, and this will be tangential to the circle, and this will be tangential to the circle. At every point you can see that what? The magnitude of the velocities keep on changing, you know. Here 5, here 4, here maybe a 6, or here maybe what? Something. The velocity is maximum only at this point. Is that clear? At every point there is a change in the magnitude of the velocity. There is a changing in the magnitude of velocity, and because of that, because of changing in what? Changing in magnitude. So I told you, whether you are changing the direction of velocity is called acceleration. Whether you are changing the magnitude of the velocity, there is acceleration. But this time there is an acceleration due to change in the what? Magnitude of the velocity. The direction of the velocity is always tangential. That is what? Tangential acceleration. That's called as a tangential acceleration, which means the direction of acceleration at any point will be what? Tangential. Is that clear, boss? It's called tangential acceleration. This is called what? Centripetal acceleration. Is that clear? Due to change in direction, there is a centripetal acceleration. So due to change in magnitude at the tangential of the circle, there is some acceleration. So that acceleration we are calling what? That is called tangential acceleration. So I want to know what will be the total acceleration here, because in the non-uniform circular motion there are two kind of acceleration. We can see that. So this will be what? I can write. This will be what? Tangential acceleration due to change in magnitude. So there is some acceleration due to center, that is towards what? Change in what? Direction. Here the change in magnitude. So listen carefully. There is an acceleration due to changing in magnitude. That's called tangential acceleration. So there is some acceleration due to change in the direction, that's towards the center. Is that clear? So what will be the total? Because here we have one acceleration and here we have one acceleration. Then we want to know what will be the total acceleration or the resultant acceleration. So the resultant acceleration acting along this direction. Is that clear? Acting along this directions. Now you can displace the what? Tangential acceleration at a point what? To the center. So whenever you are displacing the vector without changing any angle, there will be no effect. It will be same. So I can displace the tangential vector with what? The center of circle. I can displace the tangential vector to this point. It's called AT. we displaced, So here also the angle between the tangential acceleration and the what? The centripetal axis is 90 degree. And here also you can see that. And here also you can see that they are 90 degree only, Okay. And you can see that the two vectors acting along what? You can see the anti-clockwise direction. Here you can see that what will be the direction of centripetal acceleration? It's going like this. What will be the direction of tangential acceleration? It's going like this. So you can see that the two vectors going in anti-clockwise direction. It is a clockwise direction. It is a clockwise direction. Please change it. So here you can see that there is some acceleration acting along this one. There is some acceleration along this one. So you can see that the centripetal acceleration and the tangential acceleration both are moving in what? Clockwise direction. So there is a total acceleration that is will be what? Anti-clockwise direction. So according to vector sum, the total accelerations, one is going what? Anti-clockwise direction. That is equal to the sum of the two vectors going in the what? Clockwise direction. So I can take that is A tangential vector plus AC centripetal acceleration. According to what? Triangular law of additions. Two vectors moving in clockwise direction, then one vector is moving what? Anti-clockwise direction. So the anti-clockwise direction is equal to what? The tangential accelerations plus centripetal acceleration. So from this, using what? The magnitude of the resultant vector, so we studied that the total acceleration will be equal to, that is AT square plus AC square. So this will be the magnitude. Please understand this one. So this is the formula vector notation. We are getting what? Vector sum. Is that clear? So which means you know that if it is a vector, it has magnitude and direction. It has magnitude and direction. For finding magnitude of the total acceleration, we are using root over AT square plus AC square, which means tangential square plus centripetal square. Is that clear? So I can write A equal to root over AT square. So we know the value of what? Centripetal acceleration, that is V square, divided by R whole square. We studied, centripetal acceleration is equal to V squared divided by R. So this will be the magnitude of the resultant acceleration. Next, I want to know what will be the direction of resultant acceleration. So you can take that. So the resultant acceleration, it makes an angle theta with what? Centripetal acceleration. So by using this tan theta, what is my tan theta? Tan theta equal to opposite side. Opposite is what? AT. Opposite is AT. Adjacent side is what? That is called AC. Is that clear? So from this I can write, that is tan theta. I can write tan. I can take inverse. I can write the formula of centripetal acceleration. That is AT divided by V square divided by R. V square divided by R. Or we can write tan theta equal to tan inverse of tangential acceleration divided by centripetal acceleration. Is that clear, ma? Is that clear? So this is the in the case of non-uniform circular motion. In the non-uniform circular motion, there is a two acceleration. One is due to what? Changing in direction, that is centripetal acceleration. And second thing is what? Due to changing in magnitude, the direction of the magnitude changing only what? The tangential, that's called tangential acceleration. And because of that, the net acceleration will be equal to the vector sum of the individual acceleration. So for finding the magnitude of total accelerations, we are taking root over tangential square plus centripetal square divided by, I substitute the formula, and finally you can see that the tan theta, this will be the direction. This will be the direction of resultant acceleration. Is that clear, ma? Is that clear? Next, we are going to write some equations for angular circular motion, because in the kinematics, we have two types of motions we are discussing. So one is linear motion, next one is called what? Angular motion. Is that clear? So I can take in a kinematics. So we have two types of motion we are discussing. One is linear, next one is called what? Angular. Next one is called angular. Then we studied that we have three important equations in the linear motions by taking what? Acceleration is a constant. So by taking A value as a constant, which means the axis is a constant, we have a three formula, that is V is equal to U plus AT and S equal to UT plus 1 by 2 AT square, and third one is what? 2AS equal to V square minus U square. So we can use these equations by taking the acceleration as constant, that is in the case of linear motion. So coming to angular circular motion, we are taking alpha constant. What is my alpha? Angular acceleration is a constant. Here the linear axis is constant, here the angular axis is constant. I can write in place of final velocity, which means in case of linear velocity, we have angular velocity in angular circular motion. Linear velocity, please understand, linear velocity, angular velocity. Linear displacement, angular displacement. Linear acceleration, angular acceleration. So in place of V, I can write what? Final velocity, final angular velocity. In place of U, I can write omega naught, that is initial angular velocity. Initial angular velocity. And in place of S, that is displacement, linear displacement, I can take as an angular displacement. And in place of acceleration, I can take what? Angular acceleration. So we can replace all the quantities in the linear motion with what? Alpha, omega, omega naught and theta. Is that clear? Is that clear one? Please note this. And next one. So what I told you. So just imagine that the object is moving in a circular path. Is that clear? At point A, it has some initial velocity. I can take initial angular velocity, that I can take omega naught. Omega naught, this will be center of the circle. Then after some time, the velocity, or the final velocity, is that clear? So when I rotate the stone, is that clear? So the final velocity I can take, or when I'm rotating in the circular motion, so you can say that this will be what I can, after some time t, the final velocity, which means the final angular velocity will be omega. Initial angular velocity is omega naught. After some time t, by under angular acceleration. There is some acceleration, that is called what? Angular acceleration, that is acting on a particle for particular time t. So after some interval, the initial velocity is omega naught and the final velocity becomes what? Omega. And you can see that they are making some angle, with some time t, it making some angle. Is that clear? So I am going to relate all this quantity. So in case of what? Angular motion, so we can compare what? Linear motion with the angular circular motion. Is that angular motion? So in linear circular motion I wrote as V is equal to U plus AT. In angular motions, in place of V, we have omega. In place of U, we have omega naught, plus in place of A, here we have alpha into t. Is that clear? Then coming to what? Second equation, S equal to ut plus 1 by 2 at square. That I can change into what? Angular motion equal to, in place of S, we can put theta equal to, in place of U, initial velocity, here initial velocity what? Omega naught into t plus 1 by 2. In place of A, we can put alpha. In place of t square, I can put t square. This will be second equation. Then coming to third equation, that is 2as equal to v square minus u square. So I can change this equation into what? For angular circular motion, 2, I have 2. In place of A, we have alpha. In place of this, we have a theta, that is equal to final velocity. In angular circular motion, the final velocity will be omega minus, in angular circular motion or in angular motion, so the initial velocity will be what? U, but here we have what? Square, and here we have omega naught square. So these are the three equations for angular motion under what? Please under this one. Under constant angular acceleration. Is that clear, ma? And here we have a linear circular motion. For linear motion, we are taking acceleration is a constant. Is that clear? And here in angular motion, we are taking what? All angular acceleration is a constant. Here the linear axis is constant. Here the angular axis is constant. Is that clear, ma? So this is about non-uniform circular motion. Is that clear, ma? So we discussed about, first of all we discussed about what is meant by uniform circular motion, difference between uniform circular motion and non-uniform circular motion, and also I told you how the non-uniform circular motion varies from what? Uniform circular motion. I told you in uniform circular motion there is only one acceleration, but coming to non-uniform acceleration there is a two acceleration. Then first one is due to change in the direction of velocity, and second one is due to changing the magnitude of the velocity. In the non-uniform circular motion there are two types of acceleration. Is that clear? So that we resolved by using what? The concept of vector. Is that clear, ma? Is that clear? So this is about today, ma. This is about today, and then from the next class we will solve the numerical problem based on projectile motion and also what? Angular motion. Have a nice day, ma.